The universe is a place of unimaginable scale and breathtaking drama. We see brilliant stars burning with the fire of 1 trillion nuclear furnaces. We see vast, swirling galaxies, each a city of light containing billions of suns. Yet for all this spectacle, the cosmos is also filled with profound silence and deep mystery. Lurking in the hearts of nearly every large galaxy, including our own Milky Way, are monsters of such immense gravity that nothing, not even light, can escape their grasp. These are the supermassive black holes, the universe's silent giants. For decades, we believed we understood them. We thought they were either ferociously active, spewing out jets of energy, or completely dormant, sleeping peacefully for eons. To truly appreciate this discovery, we must first understand what a black hole is. And the idea is, at its core, beautifully simple. It comes from one of the most powerful theories ever conceived, Einstein's theory of general relativity. Einstein told us that massive objects don't just sit in space, they warp and curve the very fabric of space-time around them. Imagine a heavy bowling ball on a stretched rubber sheet. The sheet dips and curves. Roll a small marble nearby. It won't travel in a straight line, it will follow the curve. That, in essence, is gravity. Now imagine an object so incredibly dense, so mind-bogglingly heavy, that it warps space-time to an extreme degree. It creates a well so deep the sides are perfectly vertical. This is a black hole, a region of space-time from which nothing can escape. For every bright, ferocious quasar we found, there seemed to be many more galaxies where the central black hole was eerily quiet. Our own Milky Way is a perfect example. At its heart lies Sagittarius A, a supermassive black hole with the mass of 4 million suns. Yet, for the most part, it is remarkably peaceful. We believe that black holes are fundamental to the way galaxies evolve. The energy they release when they are active can blow gas out of a galaxy, halting star formation. Their gravity can shape the orbits of stars at the galactic center. But if they spend most of their time in a silent state, how do they have such a big impact? Enter the James Webb Space Telescope, or JWST. Launched on Christmas Day in 2021, it is the most powerful and complex space observatory ever built. Its primary mirror, a magnificent golden honeycomb structure, spanning 6.5 meters, is designed to collect light from the most distant and ancient objects in the universe. JWST is optimized to detect infrared light. This is light with a longer wavelength than the visible light our eyes can see. You can think of it as a form of heat radiation, and crucially, infrared light can pass straight through those dense clouds of cosmic dust as if they were barely there. The story of this discovery began, as many do in astronomy, with patient observation. A team of scientists was using JWST to study a galaxy known by the catalog number J2210 plus 0105. It was a perfectly ordinary-looking galaxy about 10 billion light-years away. The change was not subtle. It was a dramatic flare-up, right at the galaxy's core where the supermassive black hole was presumed to be lurking. The most astonishing part was the time scale. For 10 minutes, a region at the very center of this distant galaxy blazed with newfound energy. So, what exactly did JWST see? Astronomers broke down the light from that 10-minute flare and they saw something remarkable. The spectrum was filled with fingerprints of elements like hydrogen, helium, but the lines looked different, incredibly broad. Broad spectral lines signal extremely high-speed motion. It meant gas was swirling at a significant fraction of light speed. This was the smoking gun. Only one thing can accelerate gas to those speeds: the immense gravity of a supermassive black hole. Astronomers were seeing the birth of an accretion disk. This 10-minute event has sent ripples through the astronomical community, forcing us to rethink some of our most fundamental ideas about how galaxies and black holes coexist. The discovery implies the universe is a far more dynamic and rapidly changing place than we previously thought. We had pictured the growth of black holes as a slow, stately process, like a tree growing over centuries. This new evidence suggests it can also be a series of violent, rapid bursts of activity, like a forest fire that erupts, burns fiercely, and then dies down just as quickly, leaving a lasting impact. This changes our whole perspective on so-called silent black holes. Perhaps they are not silent at all. Perhaps they are just quiet between meals. This means that at any given moment, there could be thousands of black holes across the universe that are in the process of waking up, feasting on a star for a brief period before falling silent again. This single, serendipitous discovery has opened up an entirely new field of research. Astronomers are now actively hunting for more of these fleeting, flare-up events. The race is on to find other silent black holes in the act of waking up. By studying more of them, we can start to understand how common these events are. Are they a rare cosmic fluke, or do they happen all the time in galaxies across the universe? Future research will involve coordinated efforts between different telescopes. JWST can use its powerful infrared vision to spot these events as they happen, peering through the dust to the galactic core. But other telescopes can provide different pieces of the puzzle. X-ray observatories can study the highest energy radiation from the inner edge of the new accretion disk. Radio telescopes can search for the powerful jets of material that are sometimes launched by feeding black holes. By combining all of this data, we can build a complete multi-wavelength picture of these awakening events from start to finish. The story of JWST and the awakening black hole is a powerful reminder of a simple, profound truth. The universe is full of surprises. For all that we have learned over centuries of looking up at the sky, we have barely scratched the surface. We live on a tiny planet orbiting a very average star in an unremarkable corner of one galaxy among trillions. And yet, with our ingenuity and our insatiable curiosity, we have built tools that allow us to witness events that took place billions of years ago and billions of light years away. It is, I think, one of the most remarkable achievements of our species. Every time we build a new observatory or develop a new way of seeing, the universe rewards us with a new layer of reality, a new set of wonders to explore. We thought black holes were either on or off, loud or silent. Now we know there is a dramatic in-between, a sudden violent awakening that rewrites the rules. What other surprises are lurking out there in the dark, waiting for us to build an instrument sensitive enough to see them? What other fundamental assumptions that we hold dear will be overturned by the next generation of discoveries? This is what makes science so endlessly compelling. It is not a collection of settled facts, but a continuous journey of discovery. It is a process of asking questions, of being humble in the face of the vastness of the cosmos, and of being open to having our deepest convictions challenged by new evidence. The universe is not a static and unchanging place. It is alive with activity. Birth, death, sudden, violent transformation. It is a dynamic and evolving entity, and we are, for the first time in history, able to watch it happen. So as we continue to point our new eyes like JWST towards the heavens, let us do so with a sense of profound wonder. The cosmos is under no obligation to make sense to us, and yet, with each new discovery, we find that we can understand a little bit more of its grandeur. The 10-minute flare of a distant black hole is not just a data point, it's an invitation. It's the universe whispering to us, reminding us that there are always more mysteries to solve, more horizons to cross, and an unending frontier of knowledge waiting to be explored. The journey has only just begun.